We often picture the sun as a giant yellow ball in the sky. This image is so deeply ingrained in our minds that it feels almost instinctual. From the earliest days of our childhood, we are surrounded by depictions of a yellow sun, whether it's in storybooks, cartoons, or even the simple drawings we create with our crayons. Children's drawings, ancient cave paintings, and even modern logos often depict it this way. This consistent portrayal across different cultures and eras shows just how universal this image of the yellow sun is. It's fascinating to think that people from thousands of years ago saw the sun in much the same way we do today. But what if I told you that this familiar yellow hue is actually an illusion, a trick of the light played by our own planet? The atmosphere of Earth scatters sunlight in such a way that it appears yellow to us, especially when the sun is low on the horizon during sunrise or sunset. This scattering effect is due to the shorter wavelengths of blue and violet light being scattered out of our line of sight, leaving the longer wavelengths of red, orange, and yellow. The truth is, the sun, our nearest star, shines a brilliant white light. When viewed from space, without the interference of Earth's atmosphere, the sun appears as a dazzling white sphere. This white light is a combination of all the colors of the spectrum, blended together. This might come as a surprise, challenging our long-held perceptions of this celestial object. It's a reminder of how our environment can shape our understanding of the universe. The yellow sun we see is not a true representation of its actual color, but rather a product of the atmospheric conditions on our planet. From a young age we are taught to associate the sun with the color yellow. This education starts early, in classrooms where children learn about the solar system and draw pictures of the sun with bright yellow crayons. These early lessons leave a lasting impression, shaping our perception of the sun for the rest of our lives. This association is reinforced through countless cultural representations. In art, literature, and media, the sun is almost always depicted as yellow. This cultural reinforcement solidifies the idea in our minds, making it difficult to imagine the sun as anything other than yellow. We see it in books, movies, and even traffic lights. The yellow sun is a symbol that is instantly recognizable and universally understood. It's a powerful image that transcends language and cultural barriers, making it a convenient shorthand for the concept of the sun. But this seemingly ingrained knowledge is a result of how we perceive the sun through the filter of our atmosphere. The scattering of light by the atmosphere changes the color of the sun as we see it from the ground. This phenomenon is known as Rayleigh scattering, and it's the same reason why the sky appears blue during the day. To understand the true color of the sun, we need to journey beyond the confines of Earth and into the vacuum of space. In space, without the atmosphere to scatter the sunlight, we can see the sun as it truly is. This journey not only reveals the true color of the sun, but also gives us a deeper appreciation for the complexities of our universe. The sun's true color, a pure white light, speaks to the immense energy it generates. This white light is a result of the sun's intense heat and the nuclear reactions taking place in its core. The energy produced by these reactions is so great that it emits light across the entire spectrum, which we perceive as white. This energy, produced by nuclear fusion in its core, travels millions of miles through space to reach us. The journey of this energy is a testament to the power and scale of the sun. It takes about 8 minutes for the light from the sun to reach Earth, traveling at the speed of light across the vast expanse of space. So the next time you look up at the sun and see a yellow orb, remember that you're witnessing a beautiful interplay of physics and perception. The yellow color is a result of the Earth's atmosphere filtering the sunlight, creating an illusion that has shaped our understanding of the sun for generations. The sun's true color, a pristine white, awaits us beyond the veil of our atmosphere, a testament to the awe-inspiring power of our universe. This realization not only changes our perception of the sun but also deepens our appreciation for the wonders of the cosmos. The next time you gaze at the sun, let it remind you of the incredible journey of light and the fascinating science that shapes our view of the universe. Why then do we perceive the sun as yellow? This question might seem simple, but it actually involves a fascinating interplay of physics and human perception. The answer lies in the way our atmosphere interacts with sunlight. As sunlight travels through space, it remains largely unaltered. However, when it reaches the Earth's atmosphere, things start to change. Sunlight, despite appearing white, is actually a combination of all the colors of the rainbow. This can be demonstrated by passing sunlight through a prism, which splits it into its constituent colors. This spectrum of colors, when combined, creates the white light we see. Each color in the spectrum has a different wavelength, with violet having the shortest wavelength and red having the longest. When sunlight enters the Earth's atmosphere, it collides with tiny particles of air, water vapor, and dust. These particles are much smaller than the wavelength of visible light. This collision causes the light to scatter in different directions. The phenomenon responsible for this scattering is known as Rayleigh scattering, named after the British scientist Lord Rayleigh. Blue and violet light, with their shorter wavelengths, are scattered more effectively than other colors. This is why the sky appears blue during the day, as the blue light is scattered in all directions. This scattering effect is why the sky appears blue during the day. The blue light is scattered across the atmosphere, creating the blue hue we see. As blue light is scattered across the atmosphere, it creates the blue hue we see. However, the story doesn't end there. The sun itself appears yellowish, especially when it is high in the sky. The remaining colors, including yellow and red, are scattered less and reach our eyes more directly. This is because these colors have longer wavelengths, which are less affected by Rayleigh scattering. This is why the sun appears yellowish, particularly when it is high in the sky. The direct path of the sunlight, combined with the scattering of shorter wavelengths, leaves the longer wavelengths like yellow and red to dominate our perception. During sunrise and sunset, the sun appears even more red and orange. This is because the sunlight has to pass through a greater thickness of the Earth's atmosphere, scattering even more blue and violet light and leaving the reds and oranges to reach our eyes. So, the next time you see a child painting the sun yellow, remember that there's a beautiful blend of science and art behind that choice. The yellow sun is not just a figment of imagination, but a reflection of the natural world and the way we perceive it. To witness the sun in its true glory, we need to venture beyond the Earth's atmosphere. Astronauts aboard the International Space Station, for instance, see the sun as it truly is, a brilliant white star. Without the scattering effect of the atmosphere, sunlight reaches their eyes without any alteration. Images taken from space telescopes further confirm this fact. These images capture the sun's intense white light, showcasing its true color without any atmospheric distortion. This difference in perception highlights the profound impact our atmosphere has on our view of the cosmos. It reminds us that our earthly vantage point, while familiar, doesn't always provide a complete or accurate picture of the universe around us. The white light emitted by the sun is not a single uniform entity. It might appear as a single beam of light to our eyes, but in reality, it is a complex mixture of many different colors. This white light is composed of a spectrum of colors, each with its own unique wavelength and energy. Instead, it is a composite of a wide range of colors. When we talk about the spectrum of sunlight, we are referring to the range of colors that make up this white light. These colors are typically visible when light is dispersed or spread out. We can see this spectrum of colors when sunlight is passed through a prism. The prism acts as a tool that separates the light into its constituent colors, revealing the hidden beauty within what seems to be plain white light. The prism bends different wavelengths of light to varying degrees, separating the white light into its constituent colors. This bending or refraction occurs because different colors of light travel at different speeds when they pass through the prism. What we perceive as a rainbow is this very phenomenon in action. When sunlight passes through raindrops in the atmosphere, it is refracted, dispersed, and then reflected inside the raindrop, creating a spectrum of colors that we see as a rainbow. Raindrops act as tiny prisms, dispersing sunlight and revealing the full spectrum of colors hidden within. Each raindrop contributes to the overall effect, creating the vibrant and colorful arc that stretches across the sky. Each color in the rainbow corresponds to a specific wavelength of light, ranging from the longer wavelengths of red to the shorter wavelengths of violet. Red light has the longest wavelength, while violet light has the shortest. This range of colors is what we call the visible spectrum. This spectrum of colors, however, extends far beyond what our eyes can perceive. The visible spectrum is just a small part of the entire electromagnetic spectrum, which includes many other types of radiation that are invisible to the human eye. Beyond the red end of the visible spectrum lies infrared radiation, microwaves, and radio waves. These forms of radiation have longer wavelengths than visible light and are used in various technologies from remote controls to communication devices. Beyond the violet end lies ultraviolet radiation, X-rays, and gamma rays. These types of radiation have shorter wavelengths and higher energy than visible light. They play crucial roles in medical imaging, sterilization, and even in studying the universe. The sun emits energy across this entire electromagnetic spectrum, although the majority of its energy output falls within the visible light range. This energy is essential for life on Earth, driving processes like photosynthesis and influencing our climate and weather patterns. Understanding the full spectrum of sunlight helps us appreciate the diverse ways in which solar energy impacts our planet. From powering solar panels to enabling plants to grow, the sun's energy is a vital resource that sustains life and drives technological advancements. Scientists continue to study the spectrum of sunlight to uncover new insights and applications. By exploring the properties of different wavelengths, researchers can develop new technologies and deepen our understanding of the natural world. The study of light and its spectrum has a rich history, dating back to the experiments of Isaac Newton and beyond. Newton's work with prisms laid the foundation for our modern understanding of light and color. Today, the knowledge of the light spectrum is applied in numerous fields, from fiber optics and medical imaging to communication technologies and beyond. The spectrum of sunlight continues to be a source of inspiration and innovation,